This is a review for Chapter 4, Sections 1 through 4. The blades of a wind turbine are 125 feet long. The propeller rotates at 20 revolutions per minute. For angular speed, we're going to use the formula W is equal to the central angle divided by time, or theta over time. We can plug in the number of revolutions per minute, and then we can plug in how many radians are per one revolution. If we go all the way around the circle, that's the full 2 pi. So our answer is 40 pi radians per minute. To find the linear speed, the formula is the radius times the w, or the angular speed that we just solved. So we're going to take the 125 feet and the 40 pi radians, and let's multiply them. And here's your answer in terms of pi, as well as the precise value. With a clock, if we try to use the same formula, well, how many times does the hand on a clock revolve around in 1 minute? One time. So that whole part kind of goes away, and all we have left for W is just the 2 pi radians per one revolution, because the first part is just one revolution per 1 minute. So it's almost irrelevant. So then what's the radius for that hand? Well, they want the answer in feet per minute, so I'm going to take that 9 inches and I'm going to divide it by 12, and this gives me 0.75 feet for my radius. So if I plug that in, I have 2 pi times 0.75, and that's V is equal to RW. That's what I did there. And that gives me 1.5 pi, or 4.7 feet per minute. Clocks revolve once per minute, so it simplifies things a little bit, doesn't it? So this will be my sprinkler head, and this is the area that it covers. You imagine that it rotates around there. And to find out the arc length here, I can take a proportion of the circumference. So we are at 240 degrees out of a possible 360, and we're going to multiply 2 pi r. And this gives me 335.1 feet. Now I did that in terms of degrees. I can think of 240 out of the possible 360. It's possible you could convert it to radians and think about it out of a total 2 pi. And then use a slightly different formula, but I think this works pretty well. I'm just adapting the circumference formula, which is 2 pi r, and I'm scaling it. It's not the entire circumference, it's this proportion of the circumference. If you want to find the area covered by the sprinkler, you can take pi r squared, which is how you would find the area, and then we're going to similarly proportionally adjust it to 240 divided by 360. And if you do this, you get 13,404.1 feet squared. We're determining quadrant for the terminal side of the angle. So you can think about negative 23 over 4 pi, and 8 over 4 pi would be a full revolution. So how many times does that go in evenly? Well, that would be twice. And at that point, what's left over is a negative 7 over 4 pi. So it's like this, plus a negative 8 over 4 pi. And we're just adding all of those together. And these can be canceled out because that's a full revolution. So the only thing left is this one. And pi over 4... if we had 4 of them, that would be here, and then we have 3 more of them, so we end here in quadrant 1 at 45 degrees. For 1195, we can think about how many 360 degrees go inside of that. Now, I am a fan of 1080 snowboarding, so that's going to be a couple of revolutions there. And how much is left over? It looks like 115 degrees left over. So I start from here, and I go 90 plus an extra little bit, and here I am in quadrant 2. That's where 115 goes. For this one, you can think of plus or minus 2 pi. If you add it, that's where you get to 17 over 3 pi. And if you subtract it, that's where you get to 5 pi over 3. And they wanted a negative one, so I guess you'd have to change that a little bit, and you have to rewrite it as negative pi over 3. Because here you are at 5 pi over 3, which you could also get the same distance by going negative pi over 3. So that is the answer for that one, and there's the first one. For 1267, we're going to do plus and minus 360, so that plus 1 is a little bit easier. We have 1627. If we subtract, we have 907. If I take away 720, which is 2 full revolutions, I have 187. If I think about that graphically, that is like going right here. How can I get there in terms of negatives? That would be like negative 173, since they wanted one negative for each angle. To convert 13 over 8 pi into degrees, I can just put this, and it's like I just multiply it by 180, and this becomes 292.5 degrees. Since this is 5 radians, I can do times 180 divided by pi, and I get 286.5. For 395, this is like multiplying by pi over 180. I could write this as 79 pi over 36, or I can simply write it as about 6.7. Alright, time for 4.2. So first of all, let's remember that the x-coordinate is like the cosine of theta, and the y-coordinate is like the sine of theta. So if we think about tangent of theta, that's the ratio of sine compared to cos, which we can think of as y over x. So if we think about this particular coordinate, it's like we have built a triangle here, and the inside angle here is theta, and the top of our triangle is 12 over 13. That's how far to the right we went, and this part of our triangle is 5 over 13. If we want to find our hypotenuse, we could do so, but remember we're in the unit circle here, so it's just going to be 1. As we think about these different ratios for sine, where are we going to be at? It's going to be negative 5 over 13, because that's all we have to consider is the y-coordinate. For cosine, it's just going to be 12 over 13. The tangent is going to be the ratio of those. So you could write it as negative 5/13 divided by 12/13, but since they're both 13ths, you can just write negative 5 over 12. This next column, not too bad, you just flip them. So this becomes negative 13 over 5, this becomes 13 over 12, and this becomes negative 12 over 5. If you know the left column, the right column is not too bad. I remember that the one with the s in the middle is sine. I don't know why that works for me, but it does. So let's think about where on the unit circle negative 4 pi over 3 is. So first of all, we're heading this direction, and we have pi over 3, 2 pi over 3, 3 pi over 3, and then the next one would be right over here. So it's like an extra 60 degrees this way, in addition to the 180. So that means if we were looking at our unit circle, we're looking for 120 degrees. And we can see that our y value there is root 3 over 2. And our x value is negative 1/2. To find the ratio of those, we could put root 3 over 2 divided by negative 1/2. The halves cancel out, and the negative kind of goes to the top. So looks like that. 19 pi over 6. Remember that 12 pi over 6 would be like 2 pi, so that circles around completely. And then we have 7 pi over 6. So if you think about our unit circle, we have now went all the way around, and then we went additional pi plus 1 pi over 6. So here we are, this would be at like the 210 degrees mark. Our y value there is negative 1/2, that's our sine. Our cosine is negative root 3 over 2, and the tangent is the ratio of those. You can think of that as negative 1 over 2 divided by negative 3 over 2. Since they're both halves, they cancel out. So this would be negative 1 over root 3. We have to rationalize the denominator. So this ends up as negative root 3 over 3. Oh, sorry, there's 2 negatives there, so actually they would cancel out, and it's just root 3 over 3. Yep, I missed the negative right down there. There we go. So we're looking at this trig identity where the cosine of negative x is equal to the cosine of x. So this one is also going to be negative 1/5. And the secant here is going to flip, and it'll be negative 5. You could write negative 5 over 1, but that's just negative 5. The same thing is true here, but a little bit different because it's not
The identity here is a little bit different. The sine of negative x is equal to the negative sine of x. So that's why this 3/8 is also negative. And for the cosecant, we just flip it, and it now becomes negative 8/3. For these, you have to check the mode. We're going to be in different modes. Since I don't see any degree symbols, I think we're going to be in radians mode for pretty much all of these. So check mode. We're going to be in radians. Into our calculator, we can type in 1 over cos of negative 22.8. If we do that, we'll get negative 1.4486. This is 1 over tan of negative 0.9. We get negative 0.7936. And this one is 1 over sine of 2 pi over 3, which gives me 1.1547. So if we think about this as a right triangle, we can find the hypotenuse by taking the square root of 15 squared plus 8 squared, which is the square root of 289, which is 17. There's my hypotenuse. And given where theta is, this is adjacent and this is opposite, and this is my hypotenuse. If we think about the SOHCAHTOA, that tells us where to use which ratio. For sine, we're going to use opposite over hypotenuse. That'll be 8 over 17. Cosine is adjacent over hypotenuse. That's 15 over 17. Tangent is opposite over adjacent. That's 8 over 15. Now to find the next three, you just flip the first three. 17 over 8, 17 over 15, and 15 over 8. No triangle for this one, but if we draw it out, we can identify it like this. If this is theta and this is 1, let's call this 4, because after all, the sine of theta is going to be the inverse, so 1/4. So opposite over hypotenuse there. 1 is the opposite, and 4 is the hypotenuse. So if we want to find the missing leg, we can use the Pythagorean theorem. This is the square root of 4 squared minus 1 squared, which is the square root of 15. To find the sine ratio, well, we already did that actually. It's 1/4. The cosine is going to be 4 over root 15, which we have to rationalize. That becomes 4 root 15 over 15. For tangent, that's 1 over root 15, which becomes root 15 over 15. For these, we just flip, so that becomes 4. This is root 15 over 4. This is root 15 over 1, or just root 15. For this section, you can go to the second apps button and find these symbols, and you can actually put them in if you want. If you don't want to bother with that, just know that degree is written as is. So for cosecant, we could put 1 over sine of 44 plus the second one, the single apostrophe, is out of 60. And the third one, the double apostrophe, is out of 3600. And if we add those together and take 1 over sine of the answer, we get 1.4338. You want to make sure you're in degree mode. So we want to be in degree mode for this one. For this next part, we're going to take the tangent of 22 plus 18 over 3600 because it has the double apostrophe. And you get 0.4041. So let's draw a triangle here. We have 3,500 meters. We want to know what this x is. And our theta here is 2 degrees with 10 apostrophe. We think about the sine ratio, how it's opposite over hypotenuse, and we put into our calculator 3,500 times sine of 2 plus 10 over 60. And we get 132.3 meters. Next up, we have a diagram here like this, and this is our wire, and this is our pole. And we have a 57-degree angle of elevation, and our pole is 35 feet. So if we want to figure out the wire, we want to figure out how far from the base of the pole. So we want to figure out this one down here. So we can use the tangent ratio. The tangent of 57 is equal to 35 over x. And that tells us that x is equal to 35 divided by the tangent of 57. Plug that into your calculator, you get 22.7 feet. So for this one, if you think about a circle like this, here we are at 2/3 and 5/2. Those are our coordinates, right? So we make a little triangle, and the legs are 2/3 and 5/2. To find the hypotenuse, or the radius, we can take the square root of 2/3 squared plus 5/2 squared. This gives us the square root of 241 divided by 6. Kind of a long way to start the problem there, but since we have all of these values now, we can use them and figure them out. So our sine, we could think of this as just the y-coordinate, which is 5/2. And if I multiply this by the... So normally our sine would just be our y-coordinate because of the way that these work. The sine ratio is opposite over hypotenuse, and opposite is 5/2, and our hypotenuse in the unit circle is normally 1. However, because these are our coordinates, when we find this new hypotenuse, that is the radius, it's not 1. So if we want to consider that sine is opposite over hypotenuse, it would technically be 5/2 divided by root 241 over 6. It's very difficult to divide fractions. I think it's better to flip it and multiply. So we can do that like this. And then we have 5 times 6 is 30, divided by 2 is 15 over root 241, and we have to rationalize the denominator here. So we have 15 root 241 all over 241. All right, let's try cosine. It's going to be a similar thing. We'll have 2/3, and we would divide by our radius. But instead, let's multiply by the reciprocal. On the top, we have 6 times 2 is 12, divided by 3 is 4 over root 241. If we rationalize the denominator, we have 4 root 241 divided by 241. For tangent, it's the ratio of these two things. So 5/2 divided by 3/2. We can just use the trick to cancel out the 2's, but we can also remember that division is the same as multiplying by the reciprocal. And if you do it this way, we end up straight with 15 over 4. In fact, that earlier trick that we have been doing, 5/2 divided by 2/3, would not work because the denominators are not the same. So flipping it and multiplying is the superior method here. Good news, for the next section we are just flipping. So this becomes, well, let's go back to the previous form. Let's go back to this one and flip it so that we have root 241 on top and 15 on bottom. That way we don't have to rationalize the denominator all over again. For secant, we can do the same thing. We'll look at this one and flip it. So it's root 241 over 4. And for cotangent, this becomes 4 over 15. So I do apologize, but apparently there's a mistake in this problem. This should have been 6 over 5, not 5 over 5. And if you consider that secant is the inverse of cosine, you can change that to cosine theta of 5 over 6. You flip it. And that makes 5 the adjacent side and 6 the hypotenuse if we're using SOHCAHTOA. So if we draw a right triangle and label theta here, this is the adjacent side and this the hypotenuse. From that, using the Pythagorean theorem, we can figure out the other leg. Now let's think about these different results in consideration of our constraint, that the tangent of theta is less than 0. So if tangent is less than 0, that means it's negative. So if we look at sine, normally from this reference angle, we would choose root 11 over 6, but we're going to add that negative piece to make it negative root 11 over 6 to fit this constraint. Because otherwise, if I take sine divided by cos, it's positive. That tells us, by the way, that this can be in either quadrant 2 or quadrant 4. For cosine of theta, using this reference angle, I'm going to choose 5 over 6. And if that still doesn't make sense, here's a visualization that my cosine here goes to the right, 5/6. My sine goes down 11/6, so this is 5/6. This is the root 11, and then this is my hypotenuse, which is going to be the 6. So that's 5 over 6, and that tells us why the root 11s are all going to be negative, because I'm over here. It is possible if you made the 5/6 negative this way, and the root 11 positive, you could also end up in this quadrant. Those would be the two situations where tangent could be negative.
but I'm sticking here with the root 11 being negative, just how I'm doing it. So for tangent, which is opposite over adjacent, we're going to use negative root 11 over 5. And then for all of these, we'll flip it. So we have negative 6 over root 11, which we can rationalize to negative 6 root 11 over 11. For secant, we have 6 over 5. And for this one, we have negative 5 over root 11, which we can rationalize to have negative 5 root 11 over 11. Since we're at negative 495, you can think about in the unit circle, we have went this way an entire 360 degrees plus an extra 135. So that brings us to here. And if we want to find the reference angle, that's going to be this angle right here, theta prime, which is going to be 45 degrees. The reference is always starting from the beginning over to here, and then this little piece. The reference angle is always going to be, by the way, between 0 and 90. So that's how you can tell if you are correct. For this next one, we have negative 18 over 3 pi. So I think about, well, 6 over 3 pi would be a full revolution around. If this is my unit circle, I go 6, another 6, and another 6. And I'm actually back where I started. So this one is at 0 degrees because there's none. I just did 3 full revolutions in the negative direction. Make sure you are in radians mode, and if you are, then if you take the tangent of 4, you get 1.1578. To take the cosecant, this is 1 over sine of 17 pi over 4, and you get 1.4142.